In this video, we're going to look at expected value. A company offers a 5-year warranty on a product for $30. Replacing the product to the consumer who purchases the warranty costs the company $125. The Quality Control Division estimates that 3.7% of their products will fail within the first 5 years. What is the company's expected value for each warranty sold? Okay. So let's just review this idea in general. You go to buy something at the store and they say, do you want to buy the 5-year warranty? It's only $30. Okay, so if you buy it and the product fails or breaks, the company replaces it. That costs the company $125, but they've already gotten your $30, so it'll end up costing them $95. Okay, so their quality control division wants to keep track of what percent of times this will happen. And they found that about 1.37% of their products, which isn't very much, will fail within the first 5 years. So that means 1.37% of the time they'll have to pay that $95. The rest of the percent of the time, 99.63, they'll just get to keep the $30 from the consumer. Okay, so the expected value, they asked to find the company's expected value for each warranty sold. Okay, and for any individual warranty, they'll either gain $30 or lose $95. But what we're looking at here is, in the long run, if they sell a lot of warranties, which they want to do, they're playing the odds or the probability to make money. So sometimes the products will fail, but most of the time they won't. Okay. Right up here is a very simplified formula for finding the expected value. There's a longer, wordier version in your media lesson. But basically what you're going to do is you're going to find the probability that one thing happens. In this case, we'll say the product fails, okay, and how much money the company gains or loses. And then you'll multiply those. And then you'll find the probability that it doesn't fail and how much money the company gains. Okay, when they lose money, you write it down as a negative number. Okay, and when you add these results, you'll see what they get on average per warranty sold. So let's write this out. Let's start with probability. I'm going to start with product does not fail, just because it'll be easier on the calculator, which I'll show you in a minute, times, so if it does not fail, it's going to be a gain in dollars, okay, plus the probability that it fails times how much they lose. Okay, so the probability the product does not fail, let's just double check this on the calculator, would be the difference between 100% and failing, 1.37. That's 98.63%, and we need to write this as a decimal. So divide by 100, or just move the decimal, 0.9863. And we want to multiply that. Their gain in this case, if it doesn't fail, they just get to keep that $30. Now, plus the probability that it fails, we'll move the decimal place over 2 places. That's 0.0137. Now we want their loss. So remember, let's put the loss over here separately. They don't lose $125. They gain 30. They pay the $125. So in total, they lose $95, which we need to write as a negative here. This would be negative 95. Okay, now this is easier to put in on the TI calculator, but I just have this one on this computer. Okay, so that's why I'm putting the negative second. Instead, I'm going to subtract this value. So first we'll find 0.9863 times 30. Okay, we don't want to round till the very end. Okay, so this is 29.589. Okay, and now I'm going to do, instead of plus this, I'm going to do minus the probability times 95, just because I find the negative button weird on this thing. So minus the product of 0.0137 times 95. And that gives us 28.2875. Okay, and then since this is money, so this is measured in dollars, we'll round to the nearest cent. So the company's expected value per warranty sold is $28.29. For every warranty they sell on average, this is how much they'll make. So this is why this is such a lucrative business. Okay, let's look at the next one. A school is holding a raffle for a $500 prize. They sold 300 tickets at a cost of $2 per ticket. What is, this is a goal, so I'm going to highlight it in green. What is your expected value if you bought a single ticket? We're also asked, what is the school's expected value per ticket? And then we're given this definition of a fair game. So a fair game is when the players each have an expected value of 0. So you can think of this as the idea, looking here, the company is definitely going to make money. They're going to make $28.29 on average per warranty. Okay, if they were going to make $0 per warranty, that would be a fair deal. Okay, and that's the idea with a fair game. So if the expected value is 0, the game will be fair, and we're asked to determine that. Okay, so first let's find the expected value for you if you bought a single ticket. Okay, so for you, we want, there are two things that can happen. We want the probability that you lose times the cost plus the probability that you win times the gain. Okay. And remember, one of these is going to be negative. Okay. So since there's 300 tickets and you bought one ticket, okay, the probability you win is 1 out of 300. And the probability you lose is the other 299 times. So 299 over 300. Now we need to multiply those by your cost or gain. Okay. Now if you lose your $2. So this is going to be a negative $2. But if you win, you don't win 500 because they don't give you your $2 back. So you subtract the $2 you paid, you win 500, and your total winnings are $498. Okay, now let's do this on the calculator. Again, I'm going to put this one in first so I don't have to use the negative button. Okay, so 1 divided by 300 times 498. Okay, and now I want to subtract this part, 299 over 300 times 2. And our result is negative 0.13. Okay, we don't need the 1/3. We're going to write it as a decimal, but I'm just going to write this first, negative 1/3, which in terms of money, we would say is negative 0.33. Okay, rounding to the nearest cent, and we should put dollars in front of this. Negative $0.33, which is 33 cents. So this means if you bought a lot of tickets, on average, you lose 33 cents per game. Okay, so this is, let's write person buying ticket. On average, loses 33 cents per game. Okay, now we're also asked, what is the school's expected value per ticket? Now, we'll compute this a little bit, but I want you to think about this. Who's getting this 33 cents per ticket? Well, it has to be the school. They're the people that bought the ticket. Okay, so the expected value for the school is just going to be the opposite, or positive 33 cents. But let's see how this plays out with the numbers. I'm not going to write as much information here. We'll just make a little difference. So losing for the people who sold the ticket is winning. They don't have to pay those people $2. So this would be $2.99 over 300. They make $2 for every ticket that doesn't win. Okay. And then for the one person that wins, they lose, so negative $498. Okay. Now notice this is just a sign change of these two numbers. Okay. So the difference is going to be a sign change. But again, I'll just compute it to verify. Okay, just like if you have 3 minus 2, it's 1, but 2 minus 3 is negative 1. So $2.99 divided by 300 times 2 minus $4.98 times 1 divided by 300. And notice we get 33 cents, but it's positive. Okay, so the school's expected value is for every ticket they sell, they gain 33 cents. And that's why they sell raffle tickets. At least it's going to a good cause. Okay, and now we're asked if it's a fair game. So it'd be a fair game if in the long run their expected value, which is the long run, would be 0, and it's not. So this is a better deal for the school. So this is not a fair game. But I would say it's more fair than the warranty. Okay, so not a fair game.